Hello everyone, so let's start. My name is Wang Sheng and I'm from China Mobile as a technical manager. And I mainly take charge in the research of the NFSDN, the heterogeneous computing, and the computility network, which in another name is computing force network. So today I will take a brief introduction of the computing force network. Sorry, wait a minute. Okay, today my speech will be divided into three parts. And first, I will take a brief introduction of CFN and to introduce what is CFN. And the second part is I will take an introduction of the CFN working group which we initiated in the OIF community. And the third part, I will just talk about the CFN working group progress and the working plan this year. So let's go to the first part. And first, we'll go to the background of the computing force network. And as we know that from the industry trend point of view, now the basic large models are driving the leapfrogging the development of the AI, and also the computing and especially the intelligent computing powers has become the cornerstone of the AI. And also from the network, we can see the coming trend is that the network is also transforming from providing the information transmission services to provide the information data processing services, which is changing from the focus on the network to the focus on the computing power. And from the user requirements point of view, that the user requirements is also transforming, and from the single typed resource-based services to the task-based. We mean task-based and also the integrated services that combining the network and the computing and also AI and big data set together to provide the integrated services. And so that based on the background, so China Mobile has proposed a new concept named that's computing force network in 2021, and we defined as a new information infrastructure that deeply integrates or converts the computing and the network together. And also it can provide services, integrated services containing like AI, blockchain, like computing and big data and net, edge, terminal, and security. All these elements together. So it's aiming to provide the integrated services. And its vision is to promote the computing powers becoming a social level service like water and electricity, achieving the vision of the access network from anywhere and using computing services at any time, and you can get the intelligence service for anything. So how can the computing force network can achieve this vision? So I think from 3 points. And the first is that we can connect the dispersed and isolated computing nodes together through a high-speed network, and to make the computing power collaborative, intensive, and also inclusive, and to form integrated computing power system. This is the first point. And second, based on the storage, computing, and networking as the basic elements, and we combined with AI, big data, and other computing elements, and to realize the integrated supply of the multiple technical elements and services. And the third is that by connecting users and using our ubiquitous access network, so once the users connect to the CFN network, and it can order or can use and can adjust all his network and computing services on demand. And it's just like turn on the computing the faucet, and so you can conveniently use the computing power as services. So this is the vision of the computing force network. So this is the computing force network architecture. It has 3 layers. The basic layer we call it the infrastructure layer. It consists of the cloud, the edge, and the terminal computing resources, and also the access network, also the backbone network, and with 5G like the IP and optical networks together. So it means to provide the computing network converted infrastructure. And above the infrastructure layer, we call it the orchestration and management layer, which we are doing our great effort to build the CFN brain. We call it CFN brain, which has ability to manage and to schedule all the network and the computing resources intelligently. And also we will involve the AI large models to the CF brain. And the top layer we call it the service and operation layer. It will provide the unified operation and services to the operators and also for the users. So users can order or manage all the network, both the network and the computing services on one point, and just with one click. Okay, this is a key technologies maps of the CFN. Actually, we have 32 key technologies in the CFN, and in these 3 layers. And with the red frame marked technologies like the cloud native, like computing native, these are already covered in the open source communities. And with the green frame marked technologies like in-network computing and especially the intelligent computing, this will be covered later in the. It's also planned to push to the open source community. Okay, so the second part is the CFN working group. I will take a brief introduction of the CFN working group. So to promote the development of the CFN open source ecosystem. So China Mobile, we have led to launch the computing force network working group in the OF in July 2022. So now it has also 19 members, including all the global telco operators, device vendors, cloud providers, etc. And CFN working groups is aiming to explore the typical use cases, working out the requirements on end-to-end workflow, the architecture, and the key technology features, and especially implement the feature code, and also to cover the system integration and the testing. So this is the working group. So this is the CFN working group organization structure. So we have now 5 subgroups. For the user case and architecture subgroup, we are mainly working on the use case, architecture, end-to-end process, and this is the recommendations and for the high-level design. And also we have four technical groups. The technical groups, they are aiming to formulate solutions and promote implement. The ubiquitous computing subgroup, they are working on the scheduling of distributed and diverse computing force. The computing offload subgroup mainly works on the DPU offload for the acceleration. And the computing native subgroup, they are working on the cross-architecture compilation and also the execution of the AI workloads. And for the security subgroup, they are working on the computing power network security and to make sure the end-to-end security in the CFN. Now first subgroup is ubiquitous computing scheduling subgroup. So this subgroup is to build a unified scheduling platform for the computing resources, including the central cloud, edge, and terminal computing. and it has three key functions in this map, in this technical map of this subgroup. First is the real-time network and computing resources dynamic cognition, and the second is the efficient integrated scheduling. The third is the continuous optimization strategy. And this is the typical use case for this subgroup as video applications in real transit scenarios. As we know that in these scenarios, as the object is moving very fast, and the demand of the network and the computing is always changing. So now the current problem is that the network and the computing are independently managed and orchestrated and scheduled. So they can't meet the demand of the highly the high demand of this scenario. So this subgroup is aiming to provide the solution. It's the one solution that based on the measurement of the resources status and the business requirements. So also combining with optimization algorithms and optimization scheduling and allocation of computing resources in different time periods and different sites. To establish a collaborative technology system of the CFN network as scheduling for the industrial applications. So they want to provide a total solution. And the second subgroup is a computing native subgroup. So this subgroup is aiming to insert one basic software layer between the hardware and the AI framework, and to aiming to simplify the difficulty of the user development and deployment of the AI applications. And it contains four key technologies, like unified programming model and converters, like cross architecture compilation optimization technology, and the computing power abstraction technology, and the adaptive runtime technology. So this subgroup is aiming to enable the cross architecture development and deployment of the AI applications focused on the AI. The typical use cases is the AI applications migrations between heterogeneous the hardwares. So this is a typical scenario of IOA. So like the AI applications code and models used for the processing the video object detection or sensor data processing, etc. will be deployed along the intelligent vehicles, the driving paths. And also due to the diversity of the computing power suppliers, so in computing resources in the infrastructure, maybe the GPU, NPU, or any MLU, or any kinds of different hardwares. So it needs the application, and now is combined to the specific hardware, and it cannot be migrated freely. So this subgroup is aiming to build a total solution that just like I said, just like they will insert between the hardware and the AI framework, a basic software layer, and to enable the AI applications to migrate from GPU to NPU to TPU much easily. This is the second subgroup. So the third subgroup we now is computing offload and integration as a subgroup. And so they are just focusing on using the DPU hardware and software integration to complete the cloud platform offloading, like the management functions, network functions, storage functions, and computing functions, etc. And in order to free up the higher cost, to free up the use of the CPU resources and improve the energy efficiency. So they, especially the services like the cloud provider, they always will provide some elastic bare metal services. So in these scenarios, that is what this subgroup is focusing on. And the last is the security subgroup. So this subgroup is focused on providing the security solutions and recommendations based on the potential security risk. And also this, the security is an end-to-end problem. So they are also collaborating with other subgroups to explore building a secure and efficient new CFN network. The typical use case for this subgroup is the security storage and computing computation of the CFN. As we know that sometimes that user services are executed on the third-party nodes, which may have untrusted or low security nodes. Resulting some security problems, like the attackers can control the software execution environment, and also the encryption or the decryption, the process may be are involved in the user services, and the key is the memory is easily stored. So this subgroup is focusing on the white box cryptography technology as to improve the data storage security. So the third part is the CFN working group progress and the work plan. In 2024 and this year, as I remember, it's June that we established a new subgroup, the security subgroup, and also in 2023, and we have launched our first CFN release, the release 1 in the OID China Day. We will continue to focus on building the ubiquitous scheduling platforms, the computing native platforms, and the computing offloading solutions to establish a one-click scheduling deployments and migration solution for the intelligent computing applications. So across the cloud, edge, and architectures and vendors. So our working group plans to complete the release 2 by the end of October this year, and also we'll have the formal publishment. And also we are planning to establish the intelligent computing subgroup. And going forward, we will continue to collaborate with the industry to focus on developing the intelligent computing scenarios and the related technology research. So this is my presentation, and thank you. So, and also welcome the developers from all over the world to join our working group, and let's make the digital world much better. Thank you.